Welcome to our module on loops. It goes with the rest of Module 14, in which you learn about code moving in time and on a schedule. At the end of this module, you will be able to discuss why using loops makes sense in computer science. You will also be able to explain the 3 different types of loops in computer science and see them in action in Netlogo. Let's get started. In programming, loops are one of the basic and most powerful tools because they allow you to execute the same piece of code repeatedly. The secret is that at the end of each iteration, you test whether your loop has met a stopping condition that you have specified, like a number of iterations or a specific value that a number you are counting has reached, and so on. Let's look at this in a little bit more detail. Here is an example of finding the average of a list of numbers, on the left side without the loop, in red, and on the right side with the loop, in blue. First, we are setting the initial counter to 0 on both sides, and then on the left, the red side, without the loop, we write a line of code for each operation on each number on our list. If we had 100 numbers, that would be about 202 lines of code. If we had 101 numbers on our list, we would have to change our code and add one of the calculation blocks. Same thing with 102 or 110 numbers. In contrast, on the right, the blue side, we initialize our counter with 0 and then start our loop. The first 2 steps are identical to the right side, but the secret lies in this last step, the test to see if we're done with the list. If we are not done with the list, we go to the beginning of the loop and execute it again, then test again, until we are done with the entire list. If we are done, we move on to the next line of code. The advantage here is it doesn't matter how long your list of numbers is because the test will let us know when the last number is reached. So that test is key to analyzing our data and saving us a lot of coding work. There are 3 major types of loops: the infinite loops, conditional loops, and counted loops. An infinite loop repeats a set of instructions until the program encounters an external stop command such as Control-C, the program or computer is manually shut down, or a runtime error aborts the program. In Netlogo, when you create a button to run a procedure and you choose the forever option when creating it, you are creating an infinite loop. You click a button and it starts to run that procedure, and the only way to stop the procedure from running is to click the button again to trigger the external stop command. We will see an example of that later. A conditional loop repeats a set of instructions while a certain condition is true. You establish a conditional loop variable that is initially true and that becomes false at some point in the looping process. That false value ensures that the process exits the loop and executes the next line of code. An counted loop repeats a set of instructions a specified number of times. In this case, you must establish a loop counter to keep track of how many times the loop is run, that is, of the number of iterations. You must also know how many times you want the loop to run, or you must calculate that number elsewhere in your code. A typical counted loop will increment the loop counter by 1 or whatever number you specify each time it runs until the maximum number you set at the beginning is reached. And now let's continue on to loops in Netlogo. Let's summarize the parts of a loop. In order to build a loop, you need the loop body, which is the part of the code that is repeated. You can control the number of repeats, that is the iterations, in 2 ways. You can use a loop variable which is incremented either until a condition is met, such as the maximum number or ratio, or until a condition is no longer true, such as that there are more blue turtles than red ones, for example.
Now you're all familiar with infinite loops. An infinite loop repeats the body of the loop until one of the following things happens. A stop command is given inside the program. The loop is manually turned off, or a runtime error occurs. Now you're already familiar with this in Netlogo because you have created forever loops, which is a type of infinite loop. And the forever loop is indicated by the little circular arrows in the bottom right-hand corner of this button below. Counted loops are repeated a fixed number of times during the program. Now, you must either know how many times you want the loop to be repeated before you're programming, or you must be able to calculate the maximum number of times to repeat the loop during the program execution. Netlogo has a specific command for counted loops. It's called the repeat command, and the typical way it's used is shown below. You would say repeat and then n number. That's the number of times you want the loop to be repeated, and the loop would be contained in square brackets, command brackets. The commands would be inside those square brackets and be repeated n number of times. Let's look at an example of a counted loop in Netlogo. Here's a small Netlogo program. Right now we're going to examine counted loops. In this program we have a setup procedure which clears the world and creates two turtles randomly positioned on the Netlogo plane. In the toRepeat loop procedure, we ask turtle 0, the first turtle created, to repeat 36 times, moving forward 1 and turning right 10 degrees. As it does this, it also sets the patch color underneath itself to be green. Let's go take a look. Okay, we've already set up the program, and now we'll execute the repeat loop. When we execute this repeat loop by moving forward 1 and turning to the right 10 degrees and changing the patch underneath the turtle green, we create this circle. So that's how a repeat loop works. Conditional loops are different. They're repeated while a certain conditional statement is true. You must initially establish the conditional statement, and it must be true at some point during the program execution for the loop to start looping. The conditional statement must become false during the looping process in order for the loop to stop. Otherwise, the loop becomes infinite. Netlogo has a specific command for conditional loops. It's the while command, and it looks like this. While, and in square brackets, the conditional statement. In the second set of square brackets, you would list the commands that you want executed while the loop is looping. So the conditional statement in the first set of square brackets must be true in order for the commands to be executed. Once that conditional statement becomes false, the loop is exited. Let's look at an example. Here we are back in our simple Netlogo program, and we have a while loop procedure. In this procedure, we ask turtle 1, which is the second turtle that was created, to put the pen down and set the pen size to be 5. And we're going to say, while the P color underneath this turtle is black, move forward 1 step and set the heading to random 25. Let's take a look. So we've left the green circle in place, and we have turtle number 1 right here, and we're going to execute the while loop. Okay, now we have the wrapping on in the Netlogo world. So once the turtle started moving, it went off the Netlogo plane and came back over here, up again across the whole plane until it hit the green circle, or until the patch underneath the turtle was no longer black. And then it stopped by itself because the conditional, while P color, which is the color underneath the turtle, is black, then keep doing this loop. So that's how a while command works. So in summary, there are 3 types of loops: infinite loops, counted loops, which use the repeat command, where you repeat a set of commands a maximum number of times, and conditional loops, which use the while command. The loop is repeated while the conditional statement inside the first set of square brackets is true.
At this point, you should be able to discuss why using loops makes sense in computer science. You should also be able to explain the 3 different types of loops in computer science and how they work in Netlogo. Thank you for watching. I look forward to seeing you in a future video.